All right, technical difficulties. Now we'll go ahead and get started. But don't worry, guys. I usually talk plenty fast, so we've got a lot of stuff to cover. So, things we're going to talk about today, we're going to talk about sharding guidelines. It's meant to be like an intro, but also to get into some of the more guts and then like details from experience that we've had at Object Rocket with big clients, small clients, and people who know Mongo, people that don't know Mongo, all the different kinds that we're talking about. So, this next slide is that's what I was looking at. So some of the things that I've done history-wise, right, we'll go ahead and skip to the next slide, is like in the past Oracle DBA, 16 years Oracle DBA, long time, kind of looked, saw the future, which direction do I want to go? Hey, there's the big, bright, shiny world of NoSQL. I also happen to have a friend, David Murphy, who I'd been playing around with a little bit of Mongo at Electronic Arts where I worked before. So one of the things that I did at Electronic Arts, I worked for the studio BioWare, which is really cool because we put out Star Wars: The Old Republic, and I started there 6 months before we went live. So it was pretty amazing. It was a pretty crazy time. I kind of like the crazy times, but that just tends to work for me. So the things that we're going to talk about today, right, obviously, I already said, we're talking about sharding. We're going to talk about when not to. Just selecting the keys is always a big thing. And then we're going to go through some specific examples of things like managing sharding once you have it in place. And that includes sometimes you grow and then sometimes you get smaller and you need to adjust to that. And we'll talk about methodologies for doing that. And then we're going to take in considerations with the changes to Mongo 3.0, 3.2, it makes you think about some different things. One, do you have to shard? And that's kind of a religious word that we'll get into in a second. But first of all, what is sharding? Well, it's not, never mind, I'm not going to say that. What is sharding? Sharding equals to horizontal scaling, right? You want to go out, you want to make use of your smaller, less expensive commodity hardware, but you scale out. And you can do that locally, you can do that on any of the platforms, AWS, etc., right? Azure, Microsoft Azure, wherever you want. Virtual or physical host. If you want to manage it, you can. And then you add in all the networking and supporting layers of wherever you're going to take care of that, and that works as well. Why in the world are these type of things important? If you look up there, you can see the main reasons, right? Why do people want to use things like NoSQL anyway? Majority of the time it's due to lower cost, but also it's like the cool factor. But you also have to look at redundancy, high availability. You want to be able to just scale on the fly, and you can do that whether it's at Rackspace or AWS or Microsoft Azure, really any place, right? But you're looking at fault tolerance. And then the next thing you're going to talk about right there. Why are we doing this in the first place? Where's IBM today? Take a look at where IBM today is. They're trying to get back into the NoSQL space. They're trying to get out of the big mainframe type things that we've been before because of the cost of big iron, CPUs, etc. That's the same thing that kind of happened to Oracle to a large extent, right? They priced themselves out of the market and now they're trying to play the catch up. And along the way, all of these new things came along that made it so that you needed new solutions. You needed solutions that could actually handle this. So Oracle tried to do this historically by looking at the rack. They tried to go horizontally, but there's still all the costs involved in that. So I had a lot of experience with the rack back in the day. The next thing, again, we're looking at horizontal. Multiple smaller hosts. You want to move out, not up. So pretty simple. There's the reasons why we do it. We're talking about scalability. We're talking about high availability. We're talking about redundancy. All these things. And why are we even taking a look at it in the first place? Why do these things matter to us, right? So you have to have the performance, basically. All the new applications, all the new web applications, all the new social media applications have forced us to happen from the sheer amount of data and from the speed that we have to be looking at and able to do to facilitate that. Scale and ability to scale. Scalability, right? Redundancy, high availability, failover, automatic failover. That's one of the things that Mongo actually does pretty well, is their election process, which they've actually improved the algorithms in 3.2 to make that faster, switching over to the rack principle. So what would we do? This is kind of a funny thing, right? In looking over some statistics and things like that, I noticed that there was a bunch of things about Facebook, and it had gone out like 3 times in the last year. And so there are all these funny graphs that people were actually freaking out and going out. They didn't know what to do with themselves because Facebook wasn't there. That tells you how, that's like what happens if you lose your phone today. It's a major crisis because everything you have is your phone. How many of you even remember the majority of the people that you call as phone numbers on a regular basis? New friends? People that I've met in the last 4 or 5 years, I don't know their phone numbers. If it's not in the phone or stored in the cloud, I'm in trouble. But anyway, these are just some funny quotes we had out there, right? I particularly love the ones running out in the streets, shoving people's pictures of their kids in people's faces and say, hey, can you like this kid? Because what's the kid gonna do if you don't like it? I don't know, how's it gonna do that, right? And then just again, going back to the big data requirements. I always like these kind of images because it makes me more and more aware that the big data that's being caught and captured every day on us, it is kind of scary, and it is kind of like the Terminator when you take a look at it. But highly available, you have to be there. It has to be there all the time. So we've got the need for all these different things, and we haven't even started yet. We're just at the very tip of the iceberg, right? We've got all this data that we already have. A lot of it's not being processed, but the NoSQL technologies of today, like Mongo, and a lot of the others, are starting to be able to first do that. So it's not that. Now, it used to be just the internet of things, and then it became the internet of everything. Today, they're making it the internet of all things. And the distinction there is that it used to be just social media data, or just user data, or just game data, or whatever. And then it was log data, and event data, and any other kind of data. But now it's not just the devices, it's everything. It's the information coming from the machines as well. And that's where it's going. Why do people care? Why do the business side care? And why should you care as an individual contributor or a director or lead of your company? If you look right there, today, 2016, we're at $917 trillion. Within 2 years, 3 years, we're supposed to get to 917 billion. We're supposed to get to 1.7 trillion. We see that there. So that's it. So then why NoSQL, right? Why are we looking at the NoSQL technologies? Developers love it. As an ex-quote, still DBA, there was always the battle between DBAs and developers. And there are a lot more developers than there are DBAs. It's Oracle forcing the rigid schemas down the developers' throats. Who's going to win that war eventually, right? Yes, we know who won that one. So, and then all the costs. Primarily the management levels, they care about the cost. But then the people who matter that are writing it, the people who are on the end of the apps, and the people who are making the apps available, you care about performance, the reads, the writes. So, I always like to talk about schemaless, because if you actually still think today that you can write an application and still think that you don't have to have a schema, or at least what you're going to do going forward, you're going to end up in a bad place. Because if you just dump data into a situation, into something, without thinking what you're going to use, you've just created one huge dumpster. Garbage in, garbage out. But schemaless, semi-structured, unstructured, all these things, all these technologies. And that's the other thing, we've got all of these technologies, not just one, not just MongoDB, not just Cassandra, not just Elastic. Use the one for what it does best, right? That's this Polygon Persistence, the right language, the right database, the right tool. So here's just a comparison. You've probably all seen this. I'm going to get to the good stuff in a minute, but just the whole thing. RDMSs, right? And that's the other thing. There is still a place for the relational databases in the world. But use each one to what it does well. MySQL still more than has a place. It's probably market share has totally increased, but along with the NoSQLs. So, Polygon Persistence is what we're actually supposed to talk about next. Right there. Polygon Persistence. Here's what I'm talking about. Use the correct technology for what you have. Okay? This is just a great example. It tells you which one to use. And it found it just out on the net web. Product catalogs. I tend to disagree a little bit. I think Mongo can do a little bit more than just a product catalog. It also does really good with user logs, user information, mobile analytics, although you should do the majority of your aggregations and stuff, I would venture to say outside of Mongo still. So, but those are the reasons why you do the best particular tool. But why Mongo specifically? You can talk about growth. Mongo's number 4. It's been number 4. But look, it's creeping up. Relational, Postgres, right? Then you've got Cassandra down there and Redis. Elasticsearch is not too far behind. So there are all these different specific things that you're going to look at. User data, device data. I like to talk about MongoDB is doing a great job with user. Whenever you have high writes, heavy reads, it gives you the balanced workload. Whereas like Cassandra, for example, it's great with the writes, but some of the times the reads don't give you quite the performance. And Cassandra also takes a little bit more manageability on the other end. So, here we go. So, then the other things we're going to talk about How to shard, that's what this whole talk is about. So here's the areas that we're going to cover. We're going to look at a high-level architectural overview, processes and steps, collection, shard key selection, and then some detailed examples of when to do this and when to do that. So that's what we're going to do today. Mongo architecture, simple. Golden Gate replication actually taught me the most out of any of the Oracle technologies about replication ever, and Oracle bought them. But it's simple, it's straightforward, it works as long as you set it up correctly, you're great to go. Network connectivity is always important with any technology, with any database technology, with anything. And even with Polygon Persistence, because it's more important than ever. If you're going to be using different utilities and different tools, you have to make sure that your network is connecting and not causing an unnecessary bottleneck somewhere along the way. So, single replica set, primary, 2 secondaries, all members talk via the heartbeat, it's replicated via the oplog. The oplog is also very useful for other things, like recovery, as long as you have enough of it that you keep around and don't lose that. So that's the simple way. Then, when you reach the need point, you have to go into shards, or you should go into sharding. Sharding is a little bit more complicated. There have been some changes with the way that MongoDB does the various components in 3.2. But let's start at the first part. So you still have your single member replica set. Here we go, your shard 1, basically that's a single replica set. Then you add a couple more. So you've got a primary, 2 secondaries, you've got 3 shards, you've got up to 50 shards. The difference, and then you've got your Mongo S tier. So your Mongo S tier, think of it as your map, your data dictionary of your relational database, your query router. Without the Mongo S, they can't talk. But without the config servers, which hold your metadata, they don't know where to go. So used to, you had 3 config servers for a production environment, and only 3. That was all you could ever have, and that's all you should have unless you use the new replica set, right? So, 1 in a development environment, but 3 configs in a normal, non-replica set type thing. The reason for that, well, if you corrupt your config server, you lose your map to your data. The data might as well not be there. It's gone. It went bye-bye. So, config server is extremely important, and that's one of the reasons why MongoDB is taking the steps that they've done to make it so that the latency between the config servers, it's more like immediate, it's close, it's housed in the same, pretty much, arena, so to speak. But, the config servers talk to your Mongo S's. So one of the things about running at scale for our larger clients, we, by default, run 4 Mongo S query routers. For our larger clients, we keep adding config servers. We keep adding Mongo S layers, right? Because they need the additional processes. We have one client that will run up to 300,000 plus queries per second. We have another client that does a social media app that has 20 plus query routers, 20 plus Mongo S processes. So you have to be careful, you have to make sure that that's all set up correctly, but those are things to keep in mind, right? So your new config server can have up to 50 members in that replica set, whereas before it was just 3 individual solo members. So shard keys, there are things you have to think about, yes?
So for the config server, do they need to be in the cluster environment, or they need to be used individual servers?
Yeah, so just like anything else, you obviously want to isolate them separately. You don't want your 3 config servers in the same host, physical host, right? You don't want your MongoDBs in the same host. So they were just separate entities, separate processes that were just talk to each other, similar to the other MongoDBs, right? But they were not within the replica set, they weren't within that wrapper, so to speak. So the whole deal is now with the replica set, you get less latency, you get better communication. And the other thing is, sometimes your MongoDBs would get a stale configuration because it doesn't talk to the config servers all the time, it keeps a cached version. And so this is also improving some of that cross communication between your MongoDBs and your Mongo and your config servers.
And let's suppose in this case, 3 config servers, they communicate to each other?
Well, so anytime you make a change, it gets replicated to the config servers, right? And so if you got the wrong copy of the config server information, you could have a stale map, right? So now that's kind of what we have going on there. All right, so shard key considerations. So shard keys, so there are workarounds that you can do if you pick the wrong shard key, but we'll talk about that in a minute. But shard key, this is the single most important thing that you can do when you're designing your app and when you've decided to shard. You sit down, you take a look at all your application patterns, and you figure out your query patterns, and you figure out what your shard key can be. Because if you pick the wrong shard key, It's immutable. You cannot change your shard key once it's done, unless you go through the painful process of like 2 different methods that we'll talk about in a minute. But one of them is a Mongo dump and restore. If you've ever done a Mongo dump and restore of a multi-terabyte database instance, how long does that take? Your initial sync alone can take a long time, depending on we're talking hours, days, etc. So that's why it's so important. But the bigger thing is, if you pick the wrong shard key, your performance is going to suffer significantly. If you pick the right shard key, your query will know through the query router, through the config, exactly which shard to go to get the information. And that's what you want. You want the shortest route to get to the data, to return it faster, because that's the whole point of NoSQL databases in the first place, right? Want it to be faster. So, the other thing is, you're never going to be able to find the perfect shard key. Well, I'm not going to say never, but it's rare. Your application, you have to be a very, very good application developer in order to do that. Your application has to fit perfectly, but even then, that doesn't guarantee something's not going to change in the future. So it's very difficult to do that. You're always going to have trade-offs. And that's where like the whole replica set versus sharding decision comes in as well, right? Because do you want to have to do a bunch of scatter gathers? Do you do more reads than you do writes? You have to think about your ratios. So there's in social applications, all these different things. Your shard key, again, it's immutable, okay? You want to use it in your query because that's how you get there. The other thing you need to think about when sharding, you have your shards. You have your replica set with your 3 members. You have 5 shards, you have 10 shards. Your data is divided up based on your shard key across all these shards. If you pick the wrong shard key and it ends up all going to the same shard, then what good have you done by sharding? Because you've just hotspotted on the 1 shard or the 2 shards that most of the data resides on. So you'll be able to tell that by your disk imbalance and things like that. So you want to pick things that are easily divisible. You want things with like high cardinality. You want things with like selectivity so that it knows where to go. And you can also use compound shard keys. So you need to be careful. Like sometimes some people will pick a more normal shard key, but then they'll add a time component. Well, when doing a time component, you still need to be careful because you could still end up hotspotting your application. But it does help limit the return set, which depending on the size of your working set, depending on the size of your server, will also come into play and make a big difference. So you've got a shard, you're about to run out of space. You say, oh, okay, I picked a shard key, now I'm going to shard. And you only have, your application's pulling in 20 gigs a day, and you've got 25 gigs left, and you're halfway through the day. You're in trouble already because you haven't allowed enough time for the Mongo to balance. So when you add the shard, it's an impactful process. It's going to use write scopes, and it's going to use the balancer to move chunks from the existing shard to the new shard. You want the balance, you want that to be a happy little puppy, okay? So you spend the time the first time. Spend the time here in your design to get it right the first time. The other thing, if you're working for customers, if it's not an in-house application where you just go to the developers, and even if it is where you go to the developers, always ask extra questions. The important questions. You can't just take it immediately at first value, what they have to say. Specifically, if you're talking to new clients or new developers that don't know a lot about Mongo, and if they're coming from a relational environment, it'll be quite different. So, find out what their app does. Ask them about how it works. What's the ratio, read to writes? Are there times they're going to do batch loads? How many times a month do they do reporting? Or how many times a year do they do reporting? How important are those reports to them? If it's a client that's a commerce, how do they actually make their money? For example, they write all the time and they write all this information, but the only time they ever make any money is when somebody buys something, and that's from a query. We had a couple of customers who did that, and they were write heavy, and they told us this. And we go and we shard based on that, and all of a sudden then they come up and say, oh, well, we don't make our money until we do the queries and somebody reads. So that changed everything. We had to rework a lot. So think about too how much you're going to grow, because that's, do you start with 1 shard? Do you start with 2 shards? Do you start with 5 shards? Do you start with 5 gig shards? Do you start with 100 gig shards? Right? How fast are they going to grow? Weeks, month, whatever. And your busy times. Busy times come into play with indexes, with TTL indexes, but it comes into play with your sizing and everything else, right? If you're coming from another existing application, where are you having trouble? What are your pain points? Those things, if you think about all that early on, then you're going to fix them. So, general steps. How do you shard? You're going to profile. You're going to look at the existing query patterns. If you ask someone, say, oh, okay, tell me the top 5 query patterns that you're going to have, they'll give you a list. I guarantee you 9 times out of 10, if you go and turn the profiler on and catch all the queries, there will be at least 2 other queries in there that, oh yeah, we run those all the time too. So you need to take into account the whole load, and you need to take into account any of the special times that I talked about before. So the type of queries, right? The patterns, are they going to do aggregations? All these things come into play about sharding, because a lot of times you want to do aggregations on your secondary members so that it doesn't impact the primary performance on your other nodes, right? So, nulls. Immutable, remember immutable, but you also cannot have nulls as values in your shard keys. So, other things there are just, cardinality. Again, no perfect shard key. There's always going to be a trade-off, always. So, but you're going to get the number, and you're going to kind of go from there, right? The different questions that you kind of ask. You want to get the number of each of the type of queries. You want to get the number of times the predicate returns that they're using the lead for a particular query. This is the field that they're going to use. Okay, so then you're going to look at what specifically are you going to do. You're going to just go through there, perform query pattern analysis, get the best option. Then you've got to create the index. The balancer's on. You can't shard with the balancer on. You need to turn the balancer off. And then each database has to have sharding enabled at the database level. So it's a simple command. It comes back pretty quickly. Then you're going to shard the collection. Remember what I said a minute ago. Whenever you shard, it's actually an impactful thing. So be aware of that when you're doing that. Make sure it's a time during low activity. You add the shards to the same thing, because immediately the balancer is going to do its computations on the chunk maps, and it's going to decide what to move, when to move, etc. Then when you're all done, you re-enable the balancer, right? So, here are a couple queries that you would do to run these aggregations to determine how many times this field was used first, how many times this field was used first, and what should I look at for the key, for the shard key. So just some examples there. So, and these will all be up on the deck later, but you see pretty much exactly what there's. Okay, here's another example. When you're running your aggregations, don't do it in the middle of the day on your primary when you're the busiest. But you do want to see what's going on in the database. But you can use your secondaries. So use your secondaries to run your queries. So, and do limits, especially if it's a larger data set, it just makes sense. Here's some of the returns and counts there that you'll see. I just wanted to throw some examples up there. Here's how you actually do it. The commands are pretty simple, right? You picked out your shard key. Okay, this is good. This is what I want to run with. You're going to create your index. Okay? Use that, blah, blah, blah. Background's true. That's still true. It used to be very true in version 2.4. It became less true in 2.6, although, and so in 2.4, if you're ever running 2.4 still, if you run this in the background to create index on your primary, it will freeze once it hits your secondaries, because it runs it as a foreground process, right, on your secondary. So it still freezes your whole environment. In 2.6, they changed that behavior, and I didn't fully trust it until later versions of 2.6, but for large indexes, generally speaking, anything over 3 gig, still be careful. And you can always use the secondary index build, meaning you build it on the first secondary, you take the first secondary out, you build your index, you add it back in, you wait for replication to catch back up, very, very important, because otherwise if you have an election, you just lost data. You do the same thing for your second one, wait for it to catch back up, and then you do a step down to elect a new primary. So you still do that, but in the later versions, 3.0 and above, it handles it significantly better, but there's always better to be safe than sorry. How do you enable it at the DB level? Enable sharding for the user's database. And then you run the shard command, right? Admin command, it's always best to use the admin commands whenever possible. If you know that you have a very busy customer, you know it ahead of time. So what can you do to mitigate the impact when you shard and when you add the shards? Well, what you can do for a brand new collection, you can pre-shard, you can pre-initial chunk it, right? So you can create a script that'll tell you how to do it. You use JavaScript to create JavaScript. You run it in a screen so that if it craps out in the middle of it, it's not a crap out moment. Because those are never any fun when you have to just sit there and wait and figure out what's going on, read through logs. And then you're going to just run it. So here's a sample snippet coming up here. MongoDB That's you're connecting to a fake database, a non-real one. So you can do whatever you want there. And then here's this. I'm just creating weeks 16 and 17, and I'm doing it for this a streaming database, right? So off we go. Then once that's there, you actually run it to create what you're looking for, your admin commands. Just wanted to show you all a couple examples. That's the num initial chunks that you have there. So, and then here's what it looks like when you do it. How do you check that? SH status, right? You'll see here too, for this particular thing, I pre-created 2,000, and that costs 4 shards, puts 500 on each one. And I took 2 of them off so just so they'll all fit on the slide, but you see what's going over there. After you've created your initial chunks, your database is still going to act the way it is. It's still going to allocate the way that the application would allocate. So you see that, yes, I had 500, but now on one shard, I'm up to 1030, the other, I'm at 638. That tells you a couple things. Your sharding may not be the best, right, your shard key. That can happen for a couple of reasons. One is like, because you picked the wrong shard key. And 2 is if the data is coming in so rapidly, or if it's coming in at a date range like I talked about a minute ago, and it'll put them all where it's going to put them anyway. Right. So here's some use cases. Very different ones. But notice one thing. 3 very, very different use cases, but we're going to use _ID hashed all the time. That tells you, so that's the default when you want to have an application that has heavy writes. If you were just lazy, you never wanted to think about it, you could just put _ID hashed all the time. But you're going to run in trouble with that if you have a very heavy read application. If it's a heavy write application and you don't query it that much, or the queries aren't important, all is fine and dandy. Okay, but in the first case, so you've got a very large number of small shards. Okay, many smaller shards. Why? Primarily because your application writes a lot, and you need the additional write scopes. Second, you've got a medium number of shards and they're medium size, right? So you need the write scopes, but you also have a lot more data that's going to go in there. And you don't want to, and you do a lot of querying, so you don't want to have to do as many scatter gathers. And then the third case, you've got 5 huge shards, or 7 huge shards instead, because you need the higher resources because you have a lot of connections, or you need the higher number of queries coming in, but in all of them. And then here's a comparison chart for each of those cases. Type of applications, the number of users, the number of shards, the plans, and a basic query information that we have going on here for this. So one of the things that you'll kind of notice between your large number of small shards, 100 to 160 queries per second, whereas your smaller number of large shards, over there, 400 to 2,000 queries per second per shard, right? So up to 300,000 queries per shard. So that's really shows you the differentiation. And again, all of these are on _ID. So the number of connections per shard. Your total number of connections end up being more or less similar, except for the case where you have your medium and your medium, right? Because you've got 88,000 connections. And then there's just the logic that's behind that too, right? Large number of small shards. You're generally going to be very well balanced in your chunks unless you really messed up and picked something on a wrong shard key. But that just tells you a little bit more information there. Here's an example of a bad shard key. So you've decided that you've got an application and one of the fields that you put in there is where this source of information came from. If it came from social media, then you're talking about Facebook, Instagram, Pinterest, Tumblr, etc., Twitter. Okay? Notice that Facebook is 75 times more, it's used more, right? Than Tumblr, 6.3. So what does that tell you right off the bat? That you would have a lot more of the one than you would of the other. So then you're going up there. Bad shard key, bad performance. So you would hotspot on Facebook all the shards that would go to Facebook. So I'm going to have to hurry now because it started late. But you're hotspotting for writes, you're hotspotting for reads. You have a crying baby in the end because you have bad performance. So what are you going to do? How are you going to fix it? You have to fix it. Send in the agents. Do whatever it is you need to do. 2 real methodologies. The dump and restore. But again, if it's a huge collection, that's going to take a long time. But basic steps. Dump the collection, drop the collection, reshard the collection, recreate it, reshard, blah, blah, blah. Drain, estimate your monk change. And then that's a command to use to do that, a query that you would use to do that. Then use JavaScript to create JavaScript and go on. So here's a sample script for that, which you'll have to get later on from the slide deck as well. But that just tells you the script to generate those, and then the commands that are generated that you would actually end up running in the script. If you get into the conversation, there are two other conversations that are kind of religious wars. The one is, do I want to use one larger replica set, or do I actually want to shard? Do I actually want to go through all this? So, different people believe different things, but anytime you're reaching a point where you can't fix it by simply adding additional resources of one variety or another, that's when you need to consider sharding. And anytime you get to the point where you need a lot of write scopes, that's probably when you need to look at sharding. Now, WiredTiger alleviates some of that concern, and that's why this religious war is somewhat heating up, because now, running on the WiredTiger engine, the storage engine, there are certain workloads where you can, instead of thinking about sharding as soon, you could think about sharding later on, because it's going to handle the write loads. We'll talk about that again in a second, but basically, if you don't want to deal with sharding, you don't want to mess with the extra components, because when you have a single replica set, you do not have your config servers, and you don't have your MongoOS processes. Okay, so when you would do it, if you have a lot of reads, you don't want to have to go to 15 servers to pull back your result sets. But you have a lot of data, but you don't have a lot of activity, right? Normal resources, application knowledge. Whereas sharding takes a little bit more expertise. You're going to have a lot of writes or a lot of updates. You want to go directly, you know which shard you're going to go to because you picked a good shard key. And you need all of the resources, okay? So that's one. Don't engage in a religious war with people who have strong beliefs. Do the research, pick the one that's going to work for you. Storage engine, these are things you think about when you're going to look at storage engines and which one to use. It's not just right now, but it's your workload. No matter what you're doing, your workload is always going to be your driving factor. And that's everything from your document size, to your collection sizes, to how fast you're going to grow, to the activity patterns that you expect, all these different things. And then finally, WiredTiger versus mmap. Again, this is a really big thing. There's still a lot of WiredTiger bugs out there that we actually found a couple in version 308, 309 recently, 309, 310, that cleared up that whenever the balancer was moving chunks, it could drop data. The frequency of it happening was a very low percentage. I actually meant to list the bug number, but you go to 311, it's fine, and then once you get to 3.2, it's also taken care of in there. WiredTiger, what's it good for? Appends, frequent writes, inserts, bulk inserts, anything like that, okay? It's going to take care of a lot of your fragmentation. The one thing about Mongo, when you're not using a compressed engine, is it will leave fragmentation. As a chunk grows and it moves to the next location, it leaves that place there. And so before you know it, you're fragmented. And not only are you fragmented, but your index spaces are fragmented too. So you have to do compactions, which is blow away a secondary, resync it, recreate it, move to the next secondary, do the same thing, do a step down, elect a new primary. So that's basically, you're clearing it out by clearing out the disk. So, but mmap v1, it's still better when you have a very heavy read load. When you're primarily querying, mmap still performs better. Now there are different reasons for that, because with the WiredTiger engine, you set your cache, you have all these new threads, you can use multiple threads, but you also have cache eviction settings. And if you don't have your memory set correctly, you can run into some problems. We had that recently happen where the amount of WiredTiger cache, eviction cache, was set, and set probably a little lower than it should have been, and it needed more memory, and so it went above the 90 to 95% threshold and caused some out-of-memory errors because it was so busy thrashing trying to clear the cache that it couldn't accept the new pages. So you have to be careful with that, but you can tinker with that now. You just have to play around and get the correct setting for your particular workload again, and that's going to depend on your document size and your activity level and everything else. So MongoDB likes to talk about, oh yes, now we have document level locking. But in reality, it's more like intent level locking. So, whereas mmap still does your collection level locking. Updates in place works best in mmap still. Because if you update in place, it's going to take it, it's going to update it right there in place, just like it says. But WiredTiger rewrites everything every time it does a change. And that's one of the reasons why the cache eviction settings are so important. Because it's always sitting there moving things around. And that's one of the reasons why the fragmentation issue and the compression issue. Another good thing about WireTiger is that it keeps the indexes compressed, right? It doesn't have to uncompress the indexes, it keeps them compressed there in the memory. Complete write and replace, the cache eviction, the settings, the issues, the threads, and then of course, as opposed, anytime you have something that you expect, if you're going to do a lot of writes and a lot of updates, and you know, oh yeah, I'm going to be adding 2 fields to this particular collection in 2 weeks, or in 2 months, we're going to add this. You know that ahead of time, and you know that you're going to do that frequently, then you still may want to consider using mmap as opposed to WireTiger. But everybody these days, they want to save money wherever they can. The thing that they don't realize, disk is cheap, right? The thing that WireTiger still is going to utilize is memory and CPU. The more CPUs you have for WireTiger, the better performance you can get because you're going to have multiple threads and WireTiger will use those threads. It will also use memory. mmap will use all the memory that it can. WireTiger is not supposed to do that, but if it's sitting there and it's used up all its allocated memory, and then there's still memory left on the machine, but it needs to start thrashing and clearing and evicting pages, it's going to start using that memory. So that's why you run into some issues with some OEMs with WireTiger as well. There were some other bugs that were pretty serious recently with WireTiger relating to like data loss or potential data loss, primarily all related to memory issues and out-of-memory errors, but they're fixing those, so that's a happy place for everyone involved. So I think that I've taken all the time, and I probably talked fast again, but despite the fact that I'm from East Texas, I actually talk very fast. So that's how it is. All right, that's it. You guys, any more other questions?
Did you see significant performance drop running WireTiger with a lot of threads?
With a lot of what?
Threads.
A lot of rest?
A lot of threads. The user connection.
Oh, a lot of threads. It depends on your hardware setup, right? If you've got a lot of threads, again, it goes back to CPU, your hardware setup. The one thing that I forgot to mention about WireTiger, the compression ratio. I didn't talk about RocksDB at all because I haven't personally worked with RocksDB. RocksDB actually gets better compression ratios and supposedly some better performance numbers, but not for particularly what we were using it for before. But it's you're going to get 75 to 85% compression with WireTiger. You're really going to get 80 to 90 something with RocksDB. So that's another engine. But again, there are so many talks here about rocks with people who are actually experts. I wasn't even going to try to pretend to know something I didn't.
Okay. Thank you.
Thank you guys.